All right, so we're going to go ahead now and begin with Chapter 4. Now, we're only covering two sections in Chapter 4. We're only covering 4.1 and 4.4 because those are our only outcomes. 4.1 is exponents in scientific notation. 4.4 is multiplying polynomials. And then once we start Chapter 5, we're really going to spend a lot of time in Chapter 5 because Chapter 5 is factoring, and those are skills that you really, really need to be good at for college algebra. It's probably the most important of the material we covered to get you ready for college algebra. So we're going to go ahead and begin with 4.1. And we're going to talk about exponents here. So let's look at something that we already know. Let's say 2 to the third power. Okay. Well, we know that 2 to the third power has a base and it has an exponent. So the 2, that's considered your base, so it has a base of 2, and the 3 is your exponent. And what would 2 cubed be? Well, if we wrote it out, what does it mean if it's 2 to the third power? Well, that's just saying you've got 2 times 2 times 2, which is then 8, right? Okay, we've already talked about this before. You should hopefully know how to use a calculator to take powers. We'll show you how to do that here in a moment as well. What we really need to focus on, though, is negatives. And we need to make sure we know the difference between when a negative is inside the parentheses and when a negative is outside the parentheses. So these two are not going to be the same. Minus 2 to the fourth power is not going to be the same with the parentheses as minus 2 to the fourth power with the minus out in front. Now, why are these different? Well, they look different. Okay, these are not going to be the same. They're not equal. They're going to come out to be different numbers. And why is that? Well, when the negative is out in front and there's no parentheses, the negative just drops down. If you have parentheses, you're welcome. No problem. If you have parentheses, then what happens, I'll mark off as being here now, is it has to be wrote out, in this case, 4 times. So negative 2 to the fourth power is written out like this. It's got to be written out 4 times. And well, what do we know about a negative times a negative on each of these? Well, the negative times a negative here makes it positive 4, and that's 16. Now, what about the other side? Okay. Well, the other side, what happens with it? The negative is out in front, so that negative comes down, and that is just 2 times 2 times 2, which is then a negative 16, and you see how they're different, right? So you have to be very, very careful with the parentheses. If you have the parentheses, you write it out. If the negative is out in front, it just falls down with it. Okay? And the reason for that is order of operations. So we have to remember order of operations, because order of operations says that we do the parentheses first. So that's why we read it out like this. If there's a negative out in front, that's just multiplication, and it comes down at the end. Now let's talk a little bit about fractions. How do we take fractions to a power? How would we take, let's say, minus 5 over 4 to the third power? What would that be? Okay, let's go ahead and find this one. Well, if I have minus 5 over 4 to the third power, what we do is we write it out. Okay, and you're going to write it out 3 times because that is your exponent. And once you've got it written out the 3 times, now what do you know? How many negatives do we have? 3 negatives, so my answer is going to be negative. And we just multiply across the top, or the numerator, and we multiply across the bottom for the denominator. So 5 times 5 is 25, times 5 more makes it 125, and 4 times 4 is 16, times 4 more should make it 64. So that's going to come out to be 125 over 64, right? And 3 negatives makes it stay negative. So that's how we work with the fractions, is you write them out and we work with them. Next, we're going to talk about some of the rules for exponents. And exponents have their own rules that we have to follow. They're a little bit different. And these are in your textbook. We're going to look at each rule, and we're going to look at it with an example with variables. Okay? And we're going to look at it as an example with numbers as well. So these are all listed out in your textbook, and these are in Chapter 4. And these are actually on, all the rules are on page 285. We're going to go through each rule and we're going to talk about it. Okay, so these are on page 285. We're going to start with the product rule. Now, exponents behave a little bit differently. When you multiply, the exponents add together.
Is that an n?
Yep. It's a to the m times a to the n equals a to the m plus n power. I'm using the same variables and the same formulas as what the textbook has. Now, let's look at a couple of these. So we're going to do 2 examples of each one. How would we work with x to the 5th times x to the 4th? Well, first off, what we do is we look at our bases. So they have to have the same bases. Okay? Our bases in this case are both base x. So the x is going to come out. And then they have the same bases, so the exponents add together. And that's 5 plus 4. So my final answer would then be x to the 9th power. Okay, these are just examples here. So that's one with variables. So you just add the powers together. Now, what about one with numbers? A lot of times students make a mistake with something like this. 3 squared times 3 to the, let's say, 3rd power. That's 3 squared, 3 to the 3rd power. Now, here's where students make a mistake. What is my base? Okay, my base is 3. We do not multiply the 3's together. The bases have to be the same, and that's what comes out. So the base 3 comes out. Now, what about the exponents?
2 plus 5.
Yep, 2 plus 3, and that makes it then 3 to the 5th power. Now, how do we use a calculator? I've got 2 different calculators that are set up a little bit differently, and I'm going to show you how to use them to evaluate 3 to the 5th. We could write it out, and we can multiply out 3 5 times, but it's easier usually if we use a calculator. So there's 2 different types of calculators. You're going to have one or the other. So here's one type. This one has a caret key. Okay, so we have a caret key here. How we would evaluate 3 to the 5th out on this calculator is you type in your base, which is 3. We hit our caret key. We hit our 5, and then we hit equals. And that's going to come out to be 243. So we use our caret key. You may also have this type of calculator, and it has a YX key. And it's going to work almost the same way. So if you have this type of calculator, you're going to find that YX or XY key, and you would just type in your 3, and then YX, 5, and then hit your equal bar down here. And it's going to give you the same 243. So you either have a caret key or you have a YX key. So how you would use a calculator is you'd either type 3 caret 5 and the equal key, or you would type 3 YX 5 and the equal key. So it just depends upon which type of calculator that you have. You'll either have a caret key like this, or you'll have a YX key, or an XY key. But that's how you type them into the calculator. You really don't want to use negatives in your calculator. So what I always do is I always find the sign at the beginning. Then once I have the sign, then I can just type it in the calculator. Okay, so that's the product rule. So when we multiply, those exponents add together. The next rule is the quotient rule. Now, the quotient rule is division. And what do we know about division and multiplication? Well, division and multiplication are opposites. Addition and subtraction are also opposites. So when we multiplied a moment ago, the exponents added together. Right? Now, the opposite of multiplication is division. So when we divide, the exponents are going to subtract. And they're going to behave exactly like the product rule, except instead of adding, we're going to be subtracting. So dividing, we always subtract. So again, we're going to do 2 examples. One with variables and one with numbers. So this one, we've got y to the 8th power divided by y to the 6th power. So what are we doing? We're dividing. That means we subtract. So that's going to be y to the 8 minus 6, which is then y squared. Okay. Let's try another one. This one will be with numbers. So how about 8 to the 4th? Over 8 squared. What would that be? That would be the 8 to the 4 minus 2 power, which is then 8 squared. And 8 squared is then what? 8 squared is then 64. So when we divide, these exponents subtract. Now the one that I think is the easiest, but students really get confused about, is the zero exponent rule. Now, the zero exponent rule says any number raised to the 0 power is going to be 1. It doesn't matter what it is. It can be several variables linked together. It can be a number raised to the 0 power. It's always going to come out to be 1. Not 0, 1. So we're going to look at several examples of this. 5 to the 0 power? Well, any number to the 0 power is 1. What about xy squared, all raised to the 0 power? It's got parentheses, so the entire part is going to the 0 power. It doesn't matter what it is, because what does it come out to be? 1. What about negative 9 with parentheses to the 0 power? Negative 9 with parentheses would be, again, 1. Now, it is different if the negative is out in front. Without the parentheses, if I say negative 9 to the 0 power with no parentheses involved, okay, this one's going to be negative 1. Why is it going to be negative 1? Order of operations tells us exponents first. And 9 to the 0 power is a 1, and the negative just gets dragged along with it. So it would actually come out to be a negative 1. See the difference between those two. Anything inside the parentheses raised to a 0 power is always 1. If the negative is out in front, it just comes along with it. So that's your 0 exponent rule. A lot of times students get confused and they just forget and they say it's 0. It's not 0, it is 1. Most commonly made mistake is you'll get in a hurry and just forget that anything raised to the 0 exponent is 1, not 0. Negative exponents are fractions. Okay. Negative exponents need to be rewritten as fractions. We never leave things as a negative exponent. When it's a negative exponent, for our final answer, we always rewrite it as a fraction. So a to the negative n is 1 over a to the n power. So there's our rule. So negative exponents can be rewritten as a fraction. So what about, how about z to the negative third power? Well, z to the negative third power, we would rewrite that as 1 over z cubed, right? Because we rewrite it as a positive exponent. How about 5 to the negative second power? Well, 5 to the negative second power would then be 1 over 5 squared. And what's 5 squared? 25. So my final answer there would be 1 over 25. So negative exponents, all you do is rewrite them as a fraction. So anytime you have a negative exponent as your final answer, you flip it over and you rewrite it as a fraction. Now we're going to talk about some power rules. And these work with parentheses. So when we talk about these power rules and we have parentheses, they're going to multiply instead of add together. And they're going to distribute through. Just like we would have a 5 out in front of parentheses. You would distribute or you would push it through. Same concept here with our power rules. And we're going to look at the first one, which is a to the m with parentheses to the nth power. Well, that is a to the m in power. So when you have parentheses, these exponents are going to multiply together. So if there's no parentheses, they add. If we have parentheses, then they multiply together. So let's look at some numbers, or some variables first, and then we'll talk about the numbers. How about we look at z to the 10th power inside parentheses with the 3 outside. Well, we have parentheses here, these are going to multiply together. So that would be then z to the 3 times 10 power, which is simply then z to the 30th power. So whenever you have parentheses, these exponents multiply together. How about 7 to the 5th to the 10th power? Well, all we have to do is we write our base, which is 7, and that's going to be then 5 times 10, which is a 50. Now, we do not need to use our calculator and break this down. Anything that is much over a 4th or a 5th power is going to be too big, because it's going to be a huge number we would have to write out. So anytime you've got a number raised to a really large power, like this 50, or basically anything over a 4 or 5 power, we don't have to write it out. We leave it as it is. If we try to use our calculator, it would go to scientific notation, and it would be a huge number. So if your exponent or your power is above about 4 or 5, you can leave it as it is. Because 7 to the 50th power would, if I wrote it out, would probably take up a whole entire page of numbers. It's going to be that big because it's 7 written out 50 times and multiplied together. That's your first power rule. Another power rule that we have is using the distributive property. If we have AB to the mth power, then that's going to be A to the m, B to the m. So what we did was we just distributed that power through. So let's now look at some examples, because these are all examples up here. So let's say we have x to the 9th, y to the 4th, all raised to the 3rd power. Well, what would we do with this one? Well, that 3 is going to have to be distributed through, just like we would work with parentheses. Okay, it gets distributed through, and we multiply. So that would be x then to the 3 times 9, which is a 27, and y then to the 4 times 3, which is a 12th power. So when you have parentheses, you just distribute it through each piece. How about 7? Z to the 9th, y to the 4th, p to the negative 3rd, all raised to the 2nd power. So now we're going to use several of our rules together here. So this is going to require us to eventually use the negative exponent rule and also the 2nd power rule here. So what we're going to do is we're going to distribute through that 2. So that 2 is going to get distributed through, right through here. And that's going to come out to then be 7 squared. If there's no number, it's assumed to be a 1. Okay, so if there's no number for the exponent, we assume it's an exponent of 1 or a power of 1. And 2 times 1 is 2, so that becomes 7 squared. Then we have a z to the 9 times 2, which is 18. We have a y to the 8th power. And then we have a p to the negative 6th power. Okay, so is everyone all right with that so far?
Yeah.
Now, we do want to go ahead and break this down as much as possible. So if the exponents are small with the numbers, we want to break them down. 7 squared is pretty small because 7 squared is a 49. We've got a z to the 18th power. We've got a y to the 8th power. But what about this negative right here. P to the negative 6th. Well, that means it goes to the denominator. So that means that's going to go down below for my final answer as a p to the 6th down below. So that required us to use our negative exponent rule. We never want to leave negative exponents in our final answer. What we do is we bring them down below. And if they're negative down below, then they come up to the top. Our power rule can also be applied to fractions. So let's now look at a couple of these that have fractions with our power rule. And this is going to be that power rule part C. A over B to the mth power is A to the m over B to the m. So it just, again, gets distributed through. Nothing new. Okay, so let's look at this one here. All right, well, what will we do with this one? Well, we have parentheses again. And that 5 is going to be distributed through. And we multiply. Parentheses make us multiply these powers. So that's going to be x to the 20th power, right? Because 4 times 5 is 20. And down below, we've got z to the negative 15th power. Now, what can we never have in our final answer? Negative exponent. So if it's a negative exponent on the top, it goes below to the denominator. If it's a negative exponent in the denominator, it's going to rise up to the numerator. So in this case, this one right here is going to go up to the top. And so I would then rewrite it for my final answer as x to the 20th, z to the positive 15th power. And that would be my final answer there. So negative exponents always flip around. So if it's negative down below, it's going to come up to the top. If it's negative on the top, it'll go down below. Now let's start combining all of these rules together. So we're going to look at examples that have multiple rules put together. So let's look at this one. Let's try to evaluate this one down. Okay, not going to be difficult at all. There's very little to do here. Well, first, what do we need to do? We've got parentheses, right? So the first thing we do is we always look inside the parentheses. None of these can go together because they're all different variables. If they were the same variable, then we could combine them together. So the first thing you always do, order of operations, is parentheses. And make sure nothing can go together inside. Well, all of these are different, right? So what we have to do now is distribute that negative 3 through. And remember, what do? We multiply. So let's go ahead and distribute that negative 3 through. So that's going to be now x to the negative 27th power. Z, now negative times a negative makes it a positive. So negative 4 times negative 3, that makes it a positive 12. So let's see the 12th power there. What about p to the 0 power times negative 3? 0 times anything is still what?
One.
Well, at the end,
No.
right? But it's p to the 0 right now, right? We'll take care of this in a moment because we know this is 1. But right now, we'll just leave it at p to the 0 power. And what do we have down below? Okay. Down below, we have 5 to the negative third power down below. Almost done. We need to clean this up a bit and rewrite our final answer. So what's going to happen with these? Well, some things are going to be moved around. So this x to the negative 27th power, where is it going to go? It's going to go down below. Okay, and this 5 to the negative third power, where does it go? Up to the top. And what do we know about this p to the 0 power? That is 1. So it's gone, right? Doesn't matter because that's just 1 there. So now let's rewrite it. Then we'll clean it up if we need to. So that 5 to the negative third, that comes up to the top. That's 5 to the third power. The z to the 12th stays on top because it was positive. And the x to the negative 27th power goes down below. P to the first power, or sorry, p to the 0 power, that's just 1, so we don't even have to write it. It's gone. We can go one more step because 5 to the third is a pretty small number, and 5 to the third power is 125. So my final answer would then be 125 z to the 12th power over x to the 27th power.
Okay.
These are not difficult as long as you're careful with the rules. They look complicated, but they're really not. It's just a matter of following the rules. When we've got parentheses, they multiply. The exponents multiply. When we've got no parentheses, multiplication, we add them together. Division, we subtract them. Let's build up another one. So, what do we do on this one? Well, order of operations, always parentheses first. So we look inside, nothing can be reduced down. So nothing can be reduced down. So then we distribute this 3 through. Each piece gets distributed through. And so we've still got a 5x to the 7th out in front. So that's just staying along with it. And then what do we have here? What do we have next? We've got a 2 cubed, right? We've got a z to the 5 times 3 is 15th power. We've got an x to the 12th power. And then we've got a 3 cubed below. Now we can clean it up a little bit more. You can put parentheses around this if you want, but also remember this 5x to the 7th power, well, that is over 1, right? It's out in front, okay? It just comes down, and that's going to be the last thing that we do is multiply. So let's clean it up one more step. You can do multiple steps at once if you want to. I'm going to do each step individually. So exponents are next. We can clean up this 2 to the 3rd and the 3 to the 3rd. Over 1, and then that's going to be multiplied, put a multiplication dot here for 1, and that's going to be multiplied by 2 cubed, which is 8, z to the 15th power, x to the 12th power, over 3 cubed. 3 cubed is not 9. 3 cubed is 3 times 3 times 3, which is 27. So I broke down all of my exponents. Now we can put it all back together, and we can get our final answer. So we multiply across the top. Exponents are gone, or sorry, no, parentheses are gone, right? So these exponents are going to add if they have the same base. So 5 times 8, we know 5 times 8, that's a 40, right? Just multiplication there. Now you can either write the z first, or you can write the x first. It doesn't matter. I'm going to go ahead and just write the x first, because in alphabetical order it's first. So we have a x to the 7th and an x to the 12th. Now, do we have parentheses? No. So these exponents are not going to multiply, they're going to add together. So 7 plus 12, that makes it then x to the 19th power. And then we still have a z to the 15th power left there. And then what's down below? 27. So that is your final finished answer. Now, how do we know when to stop? Sometimes students get confused as to when am I done? When do I know I've completed this question? Well, first off, all the variables are individual. There's not two x's that we can combine together, right? There's not two z's we can go together. 40 and 27 cannot be reduced down at all, so they're done there. Do we have any negative exponents? No. If we had negative exponents, this would be the step where we would move them around. But all the exponents are positive. Okay. 27 and 40 have nothing in common, so they can't be reduced down. So that's how we now know when to stop. Okay, let's try a couple more, and then we'll take a short break. We'll probably do 2 more of these, and then we'll take a short break. I picked this one because that 5 was negative. Now we're going to go ahead and distribute that 4 through. When we have a negative in front of a number, we're going to use parentheses when we rewrite it. So we're going to begin by just distributing this 4 through. And this 5 is a negative 5. So we're going to write that as negative 5 with parentheses, because we still got parentheses here, to the 4th power. We'll deal with that in a moment. Then what about x? What do we have here? We have 8 times 4. We've got parentheses, so we multiply. And 8 times the 4, well, that makes it a 32. And then we've got 4 times that 13, and it's negative. So that comes out to be a y to the negative 52nd power, right? And what about down below? That's 2 to the 4th power. Is everyone okay with that so far? Now we need to break this down as far as we can go. We need to work with our numbers. Now what about negative 5 to the 4th power? Is it going to be a positive or is it going to be negative? We write it out. We write it out 4 times. Yep, and it'll be positive. It's even. Evens come out to be positive because negative 5 times negative 5 is 25. Another 25, and those go together to give you then 625. So that's 625 there. And then what about 2 to the 4th? No negatives, so you can just use your calculator. And I'll just put it up on the screen so you can see how it's done again. 2 to the 4th power. How would you do that in your calculator? You hit your 2, hit your caret or your YX key. 4, and what does that come out to give you then? 16. So that's going to go down below. What else has to be moved around? Well, yep, this y to the negative 52, that has to go down below. So we're now going to be left with x to the 32 power on the top and y to the 52 power down below. That is, again, your final answer. How do we know we can stop? Well, we look at everything. 625 and 16, do they have anything in common? No. X's and Y's cannot go together. Do we have any negative exponents? No. Okay, so that's how we know that we can stop. Does anybody need, everybody's got the handout, right? Everybody's got the, yep, okay, yep, I thought you needed one, Isaiah. All right. Yep, you're welcome. I'll mark you down as being here. Okay, so let's look at some more of these. And I'm going to pick some out of the textbook. And some of these are very easy. Some of them are not. Some of them take a little bit of time to go through. So let's just pick some of these from our textbook here. How about we look at question 96 on page 288. So we're going to look at page 288. And you don't need to turn to your textbook because I'm just going to write the question up here. So this is on page 288. We're going to look at question 96. And we've got a minus 5 into the 4th power over r cubed, all raised to the 3rd power. We need to be very, very careful with this negative 5 here. You've got to be very careful with those signs. So what do? We've got parentheses. N and the R cannot go together. But what we can do is we can distribute that 3 through. So if we distribute that 3 through and rewrite it, use parentheses around that negative 5. So we've got negative 5 to the 3rd power. Parentheses mean these multiply. So that's going to be n to the 12th power. Down below, we have an r to the 9th power. What about 5 to the negative 5 to the 3rd power? What's negative 5 to the 3rd power? Is it going to be positive or is it going to be negative? It's going to be negative. You can remember that 3 is an odd power, so it comes out to be negative, or you can just write it out either way. So write it out 3 times. 3 negatives stays negative, so that would be a negative 125. So what would my final answer then be? Negative 125 into the 12th power over r to the 9th power there. And that's it. Okay, let's try one more. And then we'll take a short break. Let's look at question 126. So we look now at question 126. And this is again on page 289. And this one is 3p to the negative fourth power with parentheses, quantity squared. And then we've got parentheses p cubed to the negative first power. So this is what we've got. And this is, again, is going to combine several rules together. Always do the parentheses first. So that 2 and that negative 1 needs to be distributed through. So go ahead and distribute that through. And that's going to be 3 squared. And you could write 9 if you wanted to. But just so it's not confusing for everyone, I'm just going to write that as 3 squared. And we'll break it down into 9 in a moment. So you could write 9, or you could just leave it as 3 squared. And then what about the p? Well, that's going to be p to the negative 8. And then we've got over here, p to the negative third power. Now we need to break everything down and combine as much as we can. The parentheses are gone, so that means the exponents, if the bases are the same, then the exponents will add. So what do we have? We've got 3 squared, and we know that 3 squared is 9, so that's simple enough. We're going to add these p's together, and we have a minus 8, minus 3 more makes it negative 11. Now, are we done? No. Why not? Because can we have a negative exponent left over? No. So our final answer would then be 9 over p to the positive 11th power. And that's as far as we can possibly go. So let's go ahead now and take about a 10-minute break. We'll come back, we'll do some more of these, and we'll cover scientific notation quickly. And then we'll move on to 4-4.